on my first ever thing, but that's fine. It's okay. A little bit about me and my background. Studied physics at university, started work in 1983, IBM mainframe applications development, learned SQL in 1986, DB2, those kind of stuff. Ended up being a trainer teaching COBOL and PL1 and System 370 assembly language and those kind of things. And then the mainframe market took a bit of a nosedive around the year 2000. You might remember Jess and some others probably weren't even born. And then I did a complete volte-face and went and joined a company that built publicly available GSM protocol stack for mobile phones, which was a bit of a shock from going from the biggest computers on the world to something you can hold in your hand. And a bit of culture shock thinking, oh, how hard can that be? And it was like, okay, that's very, very hard to do that. And then I had this kind of weird background of GSM mobile plus big databases. I ended up at a company called Archesa, who were making a mobile network, but for machines, not for people. So you have IoT devices in the early days when it was even M2M with a SIM in them, and they'd publish their data here, there, and everywhere. And my co-founder and I got to thinking, now, wait a minute, if I've got this IoT platform and that IoT platform and this one and that one and another one and 37 other ones, what if I wanted a bit of data from that one and a bit of data from that one and a bit of data from that one? What would I do? How would I mash those things together? And then you end up very rapidly in this kind of API mess about, this API has this format, needs this API key, I've got to read the documentation. And then exactly what Dave was saying earlier is the logic that I don't want to be in my program ends up in my program. And I've actually yet to publish it, but my next LinkedIn post is called I Hate APIs. I might
I'll buy that one.
I might end up being burnt as a heretic, but anyway, so my experience with the semantic web community was in the kind of noughties. I've been a trainer for quite a lot of my life. I taught people programming and systems analysis, and I taught people how to use this GSM protocol stack. And I thought about knowledge management and knowledge engineering. How would we do that? And saw the semantic web, and it kind of almost burst into life and then didn't. And I think the natural language processor people knackered it, the Googles of this world, because people understand semantics, don't they? If you show somebody a person of a cat, they know what a cat is. They know cats are furry, they know cats purr and those kind of things. But you show a machine a picture of a cat, they just go, it's a JPEG. I've got no clue what it is. And I started to think, we're working with interface description language. I don't know if you remember any of those things, but in the mobile comms stack, the stack was written in C and the apps were written in Java. So you needed to be able to have an interface description between the two of them, would generate stubs for you. And I thought, oh, this is interesting. It's a good idea. And then I got interested in the actor pattern and a thing called Jackson Systems development. And then the idea with Paul and I was said, why don't we virtualize the IoT devices? Why don't we have a virtual environment where a virtual temperature sensor and a virtual river level sensor and a virtual rainfall sensor can find each other and talk to each other?
Right.
And that's what we came up with. That's what we call IOTICS space.
Right.
So I've got a few slides. I can run a demo. I've got the tech deck at the back of me. I'm happy to answer as many questions as you like. And if I get boring, just tell me to shut up and I'll shut up. But let's get going.
Sounds good.
Okay, so here we go. Hopefully we can share. Share up there. You can see my screen.
Yes.
Let's just go here. Right. Okay, can you see? Cheesy title. Autonomy, yes. Autonomy, you, autonomous. So the concept of this is about how can you share data comfortably whilst retaining your own autonomy, and how by sharing data can you enable autonomous interactions? So that's, I needed a theme. That's what I reached off the shelf. So it starts for IOTICS within federated secure interactions between twins, and the twins live in evolving cooperative ecosystems. And we'll come back to a lot of this language that we use as we go through. So as far as we're concerned, a twin starts with a decentralized ID. So W3C DIDs is the subject of any subject predicate object triples in our world. Then you build the semantic metadata about that twin. What kind of twin am I? Am I an engine? Am I a person with dementia? Am I a construction site? Am I a truck full of concrete? Whatever it is. And then you have a dynamic data feed from that, which gives you real-time status updates from that thing. Then if you've got a dynamic data feed, you need metadata to describe that dynamic data as well. And then we also think of the concept of behavior. So there's some program code which interacts with the static and dynamic data, trying to keep the twin and the real world in sync with each other in two ways. So either, the real world changes, so the twin has to change, or the twin changes and it has to change the real world. So if the twin is told to turn down, then it can go and inform the real world to turn down as well. And then the idea of these ecosystems is that you give everybody a space like this in a circle. They can create their own twins inside that. And then each one of these spaces becomes a node on a decentralized hash table, and they can join a network with other twins and build this ecosystem. And then we can try to get into things like data provenance and machine-to-machine interoperability and operations in trustless environments and selective data sharing and the interoperation and co-opetition. What a horrible word.
Mm-hmm.
So that's what we're trying to do. And I often say with IOTICS, this is what we're trying to do, because I don't need to tell you guys, none of this is easy. And it's taken us 8 years of thrashing around, making lots of mistakes, getting it wrong, going down blind alleys, having people not understand us, and almost quitting as many times as I can imagine. But we're still here. We still have sponsors. We still have investors who believe in us, and we're still going. So we can't be doing everything wrong. So let's have a go back in time. This is the original concept. We used to call it the Synapse. So we'd say, here's a real device, and there's a bridge between that real device and the virtual device. Here's a real user, and there's a virtual user, and there's a bridge between the virtual user and something. And then you broker this interaction in the middle, like a synapse in between two nerves. And in the original concept, we had a central registrar, and our version 1 of our infrastructure had a central registrar. Well, we've since decentralized that registrar and federated all of the metadata. So this connection piece is a brokered interaction. So has anybody got a watch on their wrist they can wave at their camera, just for my sake of my demo? You got one, right? Good. So Dave has got a wrist watch. So Dave's metadata will say, I'm Dave, and I can tell you the time. Yeah. And then rather than me saying to Dave, Dave, what's the time, which is the way a lot of traditional IoT systems work, I say, please, Dave, can I have the time from your watch the next time you share it? And if Dave says, I like Mark, then he'll say yes. If he doesn't like Mark, he'll say no. If he does like me, the next time he says, oh, it's 5:45, then I get the time. And that's the way the IOTICS works. And we've got 7 patents on that. It's quite simple protocol about negotiating to follow somebody's shared data. And we often describe IOTICS as LinkedIn for things. Yeah. So you and your LinkedIn profile are not the same thing. So your LinkedIn profile is your metadata, is your twin. And the feed of data that goes to the different people is your data status updates. And you can also, somebody says, can I join your network? You say yes or no. So yeah, that's a social media for things in a virtualized space. My co-founder called it Second Life for Things, which dates it enormously. And I'm sure Dylan and people can't even remember what Second Life is. It's something that people, it's like it went the way of MySpace and things like that. So that's the original concept, and it tries to overcome the problem that people have about sharing data is that they think they're going to share too much. If they allow people access into their databases, they'll have some kind of land and expand, permissions upgrading, those kind of attacks to try and get at your data. So we say, well, don't bother with that. Make a virtual version of your thing, stick it out there in the cloud. And if people attack that, they're attacking a chimera. It's not a real thing. It's a digital twin. So the virtualization gives you the first step of the security model. So we've talked probably about this already. Real assets are virtualized by digital twins. The interactions happen inside IOTICS and are brokered. and then status updates and events are streamed, and then we use just the standard set of RDF triples. Each one of those little spaces has its own Apache Jenner database that you can flag. And you're probably all familiar with the FAIR data principles. We're working with the FAIR data org people to say that roughly an IOTIC space is a FAIR data point and a digital twin is a FAIR digital object. Or you can make a digital twin of a nano publication if you want to. And we're working at the moment on a project to do the next generation flu vaccine, an incentive project. We're working with them and some people in the Netherlands to try and do that, where you've got separate IOTIC spaces for each of the collaborators in this vaccine project. They publish data sets as digital twins in there, and then you federate search to find the ones that you're interested in. Yeah. At the moment, we can't do the out-of-band permissions model, but we can do that just using linked data for the moment. So this is what you end up with, a decentralized cyber physical fabric, if you want. One of the problems that we have with the IOTICS is we don't know what to call it. So if anybody has any great ideas on this call, let me know, because when I remember standing up when we first built it in 2014 in front of the High Speed Rail 2 in the UK, going, hey, we've made this thing and we don't know what it is. And that's, to a certain extent, we still don't know what it is because we can't think there's anything like it, but we do think it's useful. So if we have a look at this thing over here, you've got this loose connection of these spaces. Let's say all of the green ones are public and all of the yellow ones are private. If I'm in this enterprise here, I can federate a search which goes to all of these different spaces and saying, based on your green ones, can you tell me, have you got any electrical vehicle chargers in Swindon? And it'll go, yeah, I've got some. Here you like. And then you can go, that one looks interesting. Can I follow that one? Or can I follow that one, that one, that one, that one, and bring your data together for me? And that's it. The idea is you share and consume data when you need. Up to you. This is the whole point of the autonomy, the silly joke at the beginning, is that we have an axiom in IOTICS. The twin is in control of its own destiny. So that you say the twin shares data with whomever it chooses, whenever it chooses, and it can say no to anybody. Yeah, and you can't, from the other side, change the way that that twin works. I've described it once as trying to change people's mind by following them on Twitter. It's not going to happen. Yeah. So, and the other one for Dave's point of view is their other axiom right from the beginning is the metadata is more important than the API. Our API is very simple. Create a twin, give it some metadata, search, bind, job done.
So go ahead.
Does this kind of require that in a given ecosystem? So you mentioned IoT and you also mentioned flu vaccine. I assume those are different ecosystems. That who knows? But so in a given ecosystem, does everyone agree on the semantic model of the digital twins themselves? Not their internal model, but I assume you have to agree on that, right? Or not?
Well, yeah. So far, again, we've only been doing this 8 years, but so far we would think of it as being collaborative like that. Yeah. In that we'd all agree a common data model that we agree about, and then you can search for things based on that common data model. What we want to evolve to is being able to use inference. So, you guys say soccer, we say football, then you want to know that US soccer is EU football, OWL same as, and then hopefully we can do that. At the moment, just getting all the federated searching and the remote binding and all of that kind of stuff is tricky enough. And the decentralized ID is not exactly simple if you've ever delved into those, what with all the crypto and everything. But yes, Dave, a lot of it is places we want to go and places we are now.
Right.
Yeah. So we want to go to, it doesn't matter. At the moment, it does matter.
Sure.
But,
yeah.
but you know, some metadata is better than no metadata. Sure.
Absolutely, absolutely. And you know, we have just the tiniest stub of IoT in our upper ontology that we share with everyone. But you know, really, if all you knew that you have sensors and actuators, and you know that they can sense things like, and you know, you have a taxonomy of temperature and chemical and moisture, and you know, that's most of it right there. You know, and how far does the sensor go? You know, how many square meters will it detect motion? A few things like that, and that's about it.
Yeah. So that's basically, you know, I'm a builder. You know, I'm not a great thinker. No PhDs, no computer science degree. I'm a make it and learn by making it kind of guy. And that's what we try to do. And like I said, you know, that's if you take that approach, you're going to have to make sure that you've got very strong knees, because you're going to be crawling around quite a lot when you get it wrong and you fall over and you know, stub your toe on all of these different things. Anyway, let me just see if there's any more slides. Just one, yeah, this actually, to Dave's point here, cooperation is not the same as collaboration. Yeah. So in a collaborative world, you would agree about your common data model. In a cooperative world, you have your own agenda and you do your own thing and you choose to cooperate. Again, ultimately, we want to go to cooperation. At the moment, we're kind of stuck in collaboration. And then trying to get, I might snip out of these slides in a minute.
Can you, sorry to interrupt, can you
Sure.
elaborate on that distinction? I'm not quite getting it between cooperation and collaboration.
Okay. So our messaging guy is very strict about words, and he says, I want you to say cooperation, because two independent people can cooperate for a collective endeavor, yeah, where each one of them maintains their own autonomy and their own sovereignty. Yeah. If you collaborate, it's a closer, in his worldview, it's a closer cooperation. Sorry. Where you are prepared to share more stuff. Whereas if you want to be, you know, two people who hate each other can still climb a mountain together, can't they? Yeah. Two people who like each other can climb a mountain. I'd much rather be in the second group, but you know, it's still, you know, even if you're motivated by mutual fear, you can still climb the mountain, as well as if you're motivated by mutual trust.
Thank you.
Yeah. Yeah. If that helps.
Yeah.
Completely random. Okay. Here we go. So just start and scale. We've talked about that. Let's do a couple of use cases that we've done. This one is back in the day. This is a compressor next to the railway in the UK. This compressor would break down, and the only reason you knew it had broken down is because one red LED would come on the dashboard. And it was 3 miles away from where the people could fix it was, and you can see the amount of scaffolding that they had to climb through to fix it. So nobody wanted to go and check it every day. So we shoved a Raspberry Pi camera on it with some image recognition software and said, well, if this red light is on, that one there, just tell us. And that saved quite a lot of time. And they say, well, that's a really great idea. Why can't we do something more clever with image recognition? And this is a site safety board. And if somebody picks up the first aid kit and takes it away, we could recognize that using computer vision and send an alert. So we built a thing called the learning camera with BAM Nuttall, a big construction company, Cranfield University, and King's College and the Met Office to build this thing where we could find out what's the air quality and what's the weather like, and has anybody messed with my board. And the view is that you could train the AI and the edge to detect other things other than, you know, the missing fire extinguisher, maybe like spills on a gangway or something like that. So that's something we did. What else have we done in the world? We have built, this is London City Airport for a construction job, again with BAM Nuttall, where we tracked the river levels, the air quality, the wind forecast, the locations of, that's probably a toilet, because IoT things always seem to end up with toilets. Really trust me on this one. Is there a toilet? Is it open? Is one of the becomes important. And where we go, the wind forecast. If the threshold is above a particular thing, then you can't use the tall cranes on the construction site. So that was one with using a lot of different publicly available data sources and some internal ones as well. Geofencing, service vans arriving, and those kind of things. This is our major use case. This was with Rolls-Royce Power Systems around building a digital twin of a power generation unit that fits onto trains. So you've got here, I think it was up to 15 different subsystems that they had that informed a twin with data and metadata. And then we put a front end on it, built not by us, but we were just doing the plumbing on that. And we built things with Bosch and SAP and PCC and Azure, and these are MyBack, the people who make the stuff. So we did that. And then we expanded that one to become a whole rail delivery use case. So because we knew where the engines were on the trains, we could tell from publicly available train timetable data, is this train doing what it should? Is it going the place it should go? And is it going to end up, crucially, overnight at the right place? So we could send emails like this saying, I'm here, I should have been doing that, and I should have been arriving here. And in fact, I'm not going to get there until 5 past midnight. So that's a good thing to know. And then we built digital twins of the depots themselves, and they would publish their schedule as each new train said it was or wasn't coming. And you could say, oh, here's my schedule because this one is early, these ones have been reallocated. So we're currently working on that one with Hitachi and Great Western Rail in the UK to build that one out. And then the last and one of the latest ones we're doing is in Portsmouth International Port in the UK. We're working on trying to decarbonize the port. So remove the diesel engines and put hydrogen engines instead. And there's 4 or 5 different collaborating use cases on that, where people like the engine manufacturers of the hydrogen engines and the people with the electrolyzer and the people with the solar panels and the marine traffic and even the Navy are joining in with digital twins to build this collaborative ecosystem of separate spaces for everybody, but a joint space with everything together. Right, I'm going to stop there just for a moment. I'll take some questions and I can run a demo or so if you're interested.
So I have a question relating to the kind of how do you actually describe these things? And let me just give you a little background why I'm asking this question. So about 20 years ago, more than 20 years ago, I did some of the original work on the semantic web, and subsequently I ran a research group at Nokia Research. If anybody remembers Nokia, it was this little company that made phones.
Yeah,
120,000 people. But anyway, we had a research center, and I ran a group there that basically worked on ubiquitous computing, which was the old name basically for IoT. And at the same time, we were participating in the DARPA Agent Markup Language program, which was DARPA's take on the semantic web. And there specifically, we participated in the DAML-S effort, which was basically using ontological description of web services.
Mm-hmm. Oh, yeah.
And in our research group, we thought, well, what if we generalize the idea of services? So not just web services, but any functionality. Mm-hmm. And then what if we take these devices in a ubiquitous computing environment and we expose their functionality basically as services, sort of, you know, in a digital twin kind of manner. Mm-hmm. And then if we now use things that DAML-S might give us of service discovery, service sort of automatic service orchestration and service composition, then if these services kind of corresponded to physical activities, then basically we could say that the result of this kind of service composition and orchestration is actually the result of that is devices collaborating, devices working together. Okay, so
Yeah.
that was the basic hypothesis. This is I want to say circa 2001. We did this, and then the problem we ended up with is that, okay, so you have a device that has some functionality. How do you describe that functionality? I mean, sensors are easy. Sensors, I think, are easy.
Yep.
You know,
Yeah.
but what if the functionality is things that will there's some, you know, you actuating something, basically, that there's a physical effect. There can be all kinds of side effects of invoking some functionality. And we sort of assume that someday some kind of a classification taxonomy might emerge that would let us say things like, well, I'm able to tell the temperature, or you know, I'm able to change the temperature in this room, or something like that. But this ended up being kind of the critical problem, that we didn't know how to really describe a specific service. I mean, we could say, here are the inputs to the particular functionality, here are the outputs, here are the side effects. But that's not enough, because there could be many different kinds of services that have exactly the same inputs, exactly the same outputs, exactly the same side effects, but they do different things. So how do you really describe things in such a way that you could now, and I'm assuming, maybe I'm assuming too much, but I'm assuming, you know, that you can actually automate some of this, that you can automate discovery, and you can automate maybe one service, one device, basically handing off some stuff to another device or another service to do things, and so forth. This we found almost an insurmountable problem. The inability to describe these services in a way that would let us do this kind of collaborative work.
Okay. Wow. All right. Anyway, doing that back in 2001 was incredibly prescient. So, well done, you guys. The way you describe it is, I call twins as nano service. So if you think of a twin as being the agent for a thing in the real world, and they're described using metadata about the twin, metadata about the feeds that they can provide, and metadata about the controls that you can send them. I'll show you actually some real test metadata if you like. Where is that gone? It's hidden now.
And while you're bringing that up, Mark, I noticed we got one hand raised, and just to organize the conversation as we go along, if someone wants to talk, raise their hand, but you've got the floor, Mark.
Sure. This is our actual test data. Can you see that? Is it a bit small? To make it better. Okay, so here's a DID. The DID is an IOTB entity, which is our main base ontology. It was created in this time. It's got some labels, different languages. And the way we describe it is we say we advertise something. So if I look on that. So I advertise this. I'm a point. I'm a feed. I'm a feed about the weather. Yeah. And then in my weather feed, I have this value, which is, if we go down a bit, I'm a value. I'm the wind speed in meters per second. This is the unit I measured in, and I'm in a decimal. So the way we go down to it is just to describe, I'm this thing, I've got this feed of data, and I've got these individual data points that you combine to. Now, I'm not going to say that we've solved your problem, Aura, because I don't think we have. I think what's happened is that the ontological descriptions, the semantic descriptions of things has come on in leaps and bounds since 2001. Certainly we've found with Etsy and the Serif ontologies are beginning to make sense of this. But you've just described the most impossible problem, and that's what we set out to do. And we're, you know, if you reach for the stars, you might get to the moon, is our approach. So we haven't got to the stars yet, and I won't pretend that we have.
Yeah, I mean the stuff that you built is impressive, and I think in many ways you are much further along than we ever were at the time, and we may have had a slightly different goals, but like I said, the sensors and kind of data feeds from various sources, and we sort of generalized the idea of a sensor. Sensor didn't actually have to measure a physical quantity.
Oh, sure.
You know, I mean, it could be any data feed.
Sure.
We've had those tended to be fairly easy. So like I said, the hard part comes when you're actually trying to cause some effects somewhere.
Yeah.
Right. So I'm going to moderate a little bit. We got Michael and Eddie queued up here. So Michael, you want to go first?
Sure. My take on all IoT is that the majority of what's being captured can be described as events, and events by their very nature are n-ary. How are you modeling that in your RDF?
So an event, as far as we're concerned, is a share of one feed at one time. So you saw the RDF I just showed you. I can go back to that if you like. So what you're saying is I'm a feed about weather, and in my thing I've got these 3 different values which are described. So one of them is wind speed, the other one is the time, and the other one is that's one in French. But yeah, the idea is that all of those shared at the same time to make one event. We did do the river
that's an interesting take on it. But how about relationship between entities? I mean, for example, generally an event answers the question of who, what, when, where, why, not just attributes of the event itself. And that's why I claim that most events can be better described and best described as n-ary, in the sense of this thing is related to other contexts, and those contexts include other entities.
Oh yeah.
So,
well, you could.
How are you modeling that?
Oh well, we would just make a semantic link between the 2 digital twins. Is that what you're talking about? Or maybe I'm missing the point, but you could say.
No, it's the event you have to make. It's the event is related to the other thing, right? It's like, I'll give you the best analogy I can give you. Is like let's say we're going to go buy a ticket to see a movie. So the event is that Michael's attending the movie, but there's a location, and that's an entity, it's not an attribute. And then the time might be an attribute, but there's a person, there's Michael, there's the movie itself, which is an entity, again, not an attribute. So already we're at 3 entities related to this one event, and in fact, in most enterprises, you can end up having 20, 30, 40 events. 34 entities related to the event itself, not to entity-to-entity relationships.
Well, if you've got a decentralized ID for each one of the digital twins in your object model, then surely you could part of the event could just be the list of those things that affected. Right. If you're using the semantics to say person so-and-so bought ticket such and such to movie so-and-so at location blah-de-blah, that would be possible. We've never had to do that so far, but because we've been mainly just, sending status updates to things and responding to those. The wind is blowing this hard. The person with dementia went into the kitchen. Those kind of things. That's what we've been doing.
So why don't we go on? Eddie, you got your hand up?
Yes, sir. So maybe this is a silly question, but when going back to the example or to your project with the rail system or the trains, did it scale well as far as setting up all of the devices to keep the feeds all together? And then also was it fast? Like did it work well, and did it scale well?
Oh well, okay. The scaling, let me go back to let me share you a slightly different set of slides. This These are the crappy internal ones that we tend to show people. So this is the basic operation of IOTICS. It's like you go, here's a real engine in the real car made by a real company. You've got an engine twin with some triples, you've got a car twin with some triples, and you've got an installed on car this, so you've got a semantic relationship between the twins. Then you've got a live feed of temperature and pressure from the engine and a live feed of the latitude and longitude of where the car is, for example. And you can run a query, find me twins of 4-cylinder engines and follow their live feeds. Okay, that's IOTICS. Then you build your own space with your own twins in it, and then you mix with other people like that. Okay, so I'm going to go back to your question in a minute. Let's say this is the people who make the trains, this is the people who make the engines, and this is the people who make the stations. You can see they can scale separately. They can do different things. And each one of these circles is a node on a decentralized hash table. So that's peer-to-peer networking. So hopefully you can scale this indefinitely. We never had any problems with it. You know, you can imagine if you've got a fleet of several hundred trains that fit into one space. And the shares, we can do, I think, 180 shares a second in a space. So unless your data rates are crazy, then we can't do it. But most of the time, if you're doing a location update, I think we did every 5 seconds is enough to locate a train.
Wow.
So yeah.
Okay.
Yeah.
That's
and just to be clear, so your feed is in RDF, right?
Actually, no. Our feed is in JSON, but it's described in RDF.
Okay.
Yeah. So the contents of the feed, yeah, we would love to do. Yeah, so we'd love to do RDF feed shares, and was it the new Sparkle for streams? We'd love to do that. You know, we're 40 people. We can't do everything. It's
sure. So I also put my hand up. I'm just going to ask, kind of in general, what is your business model? What are you selling? Are you selling a platform or professional services or what? You know.
Right, we're trying to sell. Well, we don't really like the word platform, because it's people, when you think about platform, they think they're going to store their data in your platform.
Right.
And what they're actually doing is creating discoverable digital twins in our platform. So they are storing metadata in our platform and not data in our platform. Yeah. So we tend to call it infrastructure or tool set or something like that. At the moment, the way we sell it is we sell it as a service. So at the moment, we run it as an AMI in AWS. And everybody who wants a new one, you grab your AMI and you join the public network. What we're hoping to do in the future is to build a downloadable, so you can run it on your laptop, or even on a Raspberry Pi is one of the thoughts we might have, to run it and something like that small. And then you could build small networks of these devices with lots of different twins in them. We've talked to equipment manufacturers about running lo-fi, hi-fi. So you have hi-fi twins near the edge and lo-fi twins in the cloud. So you can say, this is really rich metadata, very fast data transfer down here at the machine floor where it's important. And here's some stuff you can do some modeling with upstairs, which is 1/10 of the data rate, or missing out some important pieces of metadata that you don't want people to know about. So, you know, you can imagine, you know, don't have to have one twin of each thing. You can have 20 twins of each thing if you want to. And you can have twins of simulations of those things as well if you want to. So, you know, if I sound a bit wishy-washy, it's because this is in its infancy, this stuff. I feel like we're still taking baby steps after 8 years. And there's so, you know, Aura's questions, you know, floor me. I don't know the answer to those things, but we're trying.
And sort of a semi-related, would you, and especially any of your clients, be prepared to present a short case study that in this, you know, we were going to have a data-centric, it's not the architecture forum, but just I forgot what we're calling it, data. Why should you become data-centric? Why should you, you know, use triples and all this kind of stuff? You know, if you had somebody who wanted to do a case study that said, you know, here's what we did, and here's why we did it, and it works.
It'd be difficult to find. Probably the best one would be the rail use case, but it would be difficult to find somebody who'd want to come and do that at the moment, because it's all a bit hush hush in the rail. Hitachi are taking over from where Rolls-Royce, because Rolls-Royce and rail transport took a total nosedive in COVID, and they dumped us, unfortunately.
Oh, yeah.
Yeah, you know.
Well, give it some thought. If you think of somebody,
we'd definitely love
I think
to, but probably
it's
the
a
rail
great
use
story.
cases.
Yeah,
the rail use cases that is our PS to resistance, including the really cool things like as the train moves along, if the engine is running, it sucks pollen through the air filters, and they get clogged up. So we said, well, why don't we follow the European pollen forecast and make digital twins of the pollen forecast? As the train moves, it finds and binds each new pollen forecast and then says, is my engine running? Okay, I'm accumulating pollen in my engine. At the end of the day, you can tell the people at the depot that they need to brush off the pollen off the things, but only if the engine is running. So you've got a real mixture of static and dynamic data helping you to do these things. That's almost my favorite thing about IOTICS is that mixture. And there's the places we'd love to go, like, could we run a Sparkle query across static and dynamic data? So not find me traffic lights in the smart city, but find me traffic lights in the smart city which are currently red.
Yeah.
That would be interesting.
Yeah.
And then you can imagine the connected autonomous vehicle coming up to the smart city and just binding to the local data sources as it went through. I'll have
I think we just lost your audio, or at least I did.
Yeah, I lost it.
We lost your audio, Mark. No audio. We're not hearing you.
Well, I had a question for the audience, and I'm wondering, since Mark is kind of backed into using the semantic standards, are there insights that he has that are surprising to you?
Hi there. Sorry, I ran out of battery.
Yep.
Can you hear me?
Yep.
Yes.
All right, cool. So did you get the connected vehicle comes to autonomous? Sorry, connected vehicle comes to smart city kind of use case. That's the sort of thing we're thinking we might be able to enable if you have this location-based find and bind.
Yeah.
Took another hand up. Oh, Alan's got his hand.
Oh yeah, Alan's got his hand up.
Let's see. Can you all hear me?
Yeah.
Okay.
Okay. So I'm wondering, Mark, since you sort of backed into the using the semantic standards after you were working with all the other preparatory things that you've been working on, are there things, audience, that Mark has pointed out that are surprising and perhaps useful to you? Given that he is, he's an outsider who's joined our community. Just I don't know how long you've been working with the semantic standards, Mark.
8 years, 9 years.
Okay, so you have been working with it for a while, and then not a lot of us may be working with the decentralized identifiers yet. I'm sort of assuming. So are those kinds of approaches that Mark is using now, are they any way surprising or not, or is it just totally unsurprising?
I guess that's not directed at me, that question. That's
Yeah.
No, we're trying to get some participation here.
Here's my 2 or 3 reactions. One, I think it's very novel, this idea of the interface being push or a feed, and it does get away from the whole API nonsense, all that kind of stuff. I think that's interesting and innovation. Weirdly, your definition of a digital twin almost makes any object in a graph a digital twin, except that they don't have a feed. So every object in a graph is a digital representation of something in the real world, but the extension is yours publish feeds.
Yeah.
Yeah.
We can. Well, we can't yet, but we want to be able to put arbitrary triples into the data store in order to, for example, trains are made of carriages. Yeah. But you might not get any special data out of the carriages. So you might want to say, I'm a train and I've got these carriages, but they're not twins because they don't really have anything interesting to say.
Yeah. Right.
Right. So that kind of thing.
Yeah.
we're working on that. Again, we've built what we think is a generic capability, and we want use cases now to flesh some of these problems out, because it's easy to sit where I am now and go, it's all great and wonderful. No, it isn't.
Yeah. So Michael Eschol's got his hand up.
Yes, I was very intrigued by your slide early on where you said, we don't know exactly what this is and we don't know what to call it. So I find that always I'm attracted to that challenge. What exactly is it? And so I'm just going to ask, so what to call it is essentially follows what it exactly is. And so it seems it's a network of something. What's your description of exactly what it is, and or maybe what it does? I'm just trying to help out here, maybe, so we all can understand better what exactly you've done.
I would, if I was my arm twisted up my back, I'd say it was a cyber physical fabric.
Or maybe because it doesn't have that cyber kind of spin to it as so much. I'd probably say it's an ecosystem fabric.
Decentralized digital twin ecosystem in a there we go.
Yeah, something like that. It's probably an acronym. It probably spells something, but
yeah, it's too many words. There's too many syllables.
Yeah, and let me riff just a little bit on Aura's comment. I think he's right, and you're right that describing sensors is way easier than describing what an actuator actually can do. But when you think about it, there's less people you have to communicate with about the actuators. I'm just thinking my garage door. I have an actuator. Punch this button and the door opens. But a whole bunch of people, anybody could drive down my neighborhood and sense whether the door is open or not.
Yeah.
But hopefully I only have to convince a few people what the actuator does. And so, it doesn't make the problem go away, but I think it narrows the scope, because there's very few people I want lowering the cadmium rods in my nuclear reactor, and they better know what a cadmium rod is before they do that.
Yeah,
so Peter,
sorry, can I just answer that and I'll come to Peter?
Yeah.
These were the kind of mental experiments we were doing back at the beginning. When you have controls, we use the same brokered interaction for controls as feeds. So here's a request to follow me. Okay, fine, you can follow me. You can tell whether my garage door is open or not. Fair enough. But if you want to be the one who comes and says, can you close it, then you better be on a special list of people that I will allow to do that. So that's how we built the brokered interaction piece into it. Fine. Sorry, Peter.
Yeah,
but if you're engaging with somebody else's twin, you're only getting what is their last publication, aren't you? You're unable to actually actively probe and prompt to get a current one.
Oh no, yeah, you get a last shared value when you follow. So if you with the example with Dave and his time, I said, okay, Dave, can I have the time of your watch? He says yes, and I'll get whatever it is now, 25 plus 6. Yeah. But only the next time he chooses to share.
Yes.
It might be tomorrow. He may be very bad at sharing the time. He says, oh, it's 12 o'clock tomorrow. Then I'll get the time.
Yeah. So I mean, the problem with that is that you always have to have a system of triggers. So it's less kind of like attention. You can look at it when you want to look at it, but that's when you want the current value, whereas you're only going to be given the current value when Dave allows it.
Yeah, but that's about having.
So therefore, you've always got to be monitoring it to see whether or not you've got a change in.
Yes. So that's a really good point, Peter. In the system is built around long-running processes that sit and wait.
Yes.
Now we could put things like that, which did the sitting and waiting and fired off Lambda functions or something in the background. We could do that way, but my background
in that way, it's a little bit different. So in some respects, what you're looking at is something that's very similar to the brain, in that you've got a whole bunch of independent sort of inputs. But the thing about attention is that a lot of time with the brain, you get signals coming in and you just shut them down and you put a reminder on what's going on. So for example, with vision, you'll keep in memory, you're not going to be sampling everything. You'll sample it occasionally, but then when you want to, you'll draw your attention to it and you'll take in a high volume feed, and you're unable to do that. So you may have a desperate need to know the condition of the garage door that Dave mentioned, but you're stuck with the fixed image of it open, even though it might be shut.
Well,
unless he's actually allowed you to.
Well, yes, but you'd hope that Dave would share when he shut his garage door, as well as
yeah. So there's a lot of hope in the world, and no mechanism for kind of like prompting him to say, please, just desperately need the current state.
Well, you might be able to do that by a control. You might be able to prod him via a control and say, please share. That might
okay.
Yeah, right. That would work, but we haven't come across that use case as yet in our things. We've got another hand up from Ed.
Ed's got his hand up. Yep.
Yes, sir. So I'm hearing what it is, and that's really cool what you guys have done. And can I ask why and what the initial use cases started out as?
Well, why was because we were
APIs, right?
Yeah, well, one is I hate APIs. That was the first thing. The second was the multiplicity of IoT systems that were coming up.
Yeah.
There was GE Predix, and then there was ARM have one, and Cisco have one, and Microsoft have one, and AWS has one. And then you go, oh, really? Do I have to go to? If I wanted, my classic example is, should I cycle to work today? So I want to know, what's the weather, what's the traffic, what's the air quality, is there a bike available in the local bike station?
Mm-hmm.
That's 4 separate API. Yeah, those 4 APIs was the main driver. It's like, oh crap, this is awful. Yeah.
Yep. Agreed.
Does that help, Eddie? Does that answer your question?
Yes, it does. I guess on the enterprise scale, now that you guys have actually gotten to the point where it's becoming like a sellable product, now are you gearing towards the same concept of wanting to have, the availability? Like what's the market that you're trying to reach and impact?
It's mainly what we call collective endeavor. Yeah, so like the rail use case is great because the people who make the trains are not the same as the people who run the trains, not the same as the people who maintain the trains. They don't maintain the track, and they don't maintain the stations, and you've got all of these different people with their own interests that collectively want to achieve something.
Yes,
that consulting use case is very much.
I think we got time for one more question. Michael Sullivan has his hand up.
Yeah, have you looked at the Solid project at all?
Yeah, that's the Tim Berners-Lee thing, is that right?
Yes, yes.
We've looked at it, and it looks really interesting. Like, is that personal data wallets and those kind of things? I think that could be really, really handy. We've thought about, I was trying to remember something. Oh, yeah. Single tax entity in the, what is the equivalent in the UK of your IRS? Yeah, so it's called Her Majesty's Revenue and Customs. They have all these different systems about when you pay VAT, do you drive a car, do you have a passport, do you have those kind of things, and who are you actually? If you're Jay Smith in there and John Smith in there and Jonathan Smith in that one, but it's still you. So you can have a digital twin of the person with their personal data vault as attached to it via a data link. That's the kind of thinking we're thinking where that would be really, really useful. But there's a son of a bitch problem, that one, I can tell you. Validating that Jay Smith and John Smith and Jonathan Smith are the same person. Yeah. But at least you've got somewhere to put it. That's the only thing I can say is that you never had a bucket to put that data in before.
Yeah, in fact, when we kicked off right at the beginning, as I was describing our data-centric architecture forum, one of the 10 problems to be solved is exactly that, a generalized entity resolution in the architecture. Yep.
Smooshing, isn't it called, the pattern?
Yep.
Oh, wow. Well, it's past, everybody. I've had such a great time. Thank you for having me.
Yeah, no, it was excellent. Very
Yes,
thought-provoking.
thank you.
Yep.
Thanks,
Sure.
Mark.
Thank you.
Appreciate it.
But yeah, well, catch me on LinkedIn or email me, or I'm going to be coming to these for the future. So if you
Yeah.
want to listen
Okay.
to
Yeah.
some-
Good. Make sure, Melissa, do you have them on the invite list? Yeah. We'll just make sure you get on the invite list, and love to see you again.
Sure. Well,
Okay.
that'll be next year, won't it? Be January.
Yep. Yep.
Well,
Yep.
have a happy holidays, and I'll
Great.
see you in the
Likewise.
new year. Okay.
Okay.
Bye,
Take care.
everyone.
See ya.
Bye.
Thanks, everybody. Bye.
Bye.
Bye.